In this video, we're going to look at oxidative phosphorylation. Now, oxidative phosphorylation is the endergonic synthesis of ATP from ADP in PI that is catalyzed by ATP synthase, or some people will call this complex 4. Now, the energy to make ATP is gained from the transfer of electrons from complex 1, 2, 3, and 4. As we saw in our previous videos, these complexes happen in steps, so the energy has to be conserved somehow, so we can use it later to make ATP. Basically, we're doing energy coupling for the energy we get from these complexes 1 through 4. We're going to spend it in complex 5, or ATP synthase. And the way we conserve that energy is called chemiosmotic theory. And chemiosmotic theory says that when we're moving electrons through these different complexes, the energy that we're gaining from that, we're going to use to pump hydrogens from the matrix, which is low hydrogen concentrations, to the intermembrane space, which is high hydrogen concentrations. This will create a proton gradient. And by allowing the protons to naturally flow from high to low through the ATP synthase, we can use this energy to make ATP. So how do we know that this theory is actually what's going on? Well, some key experimental observations have been made that support the chemiosmotic theory. One, oxidative phosphorylation can only occur if we have an intact inner mitochondrial membrane. 2, the membrane will not allow ions such as hydrogen, OH, potassium, or chlorine to flow through it. 3, during the electron transport chain, we see that we're pumping hydrogens from the matrix into the intermembrane space. We can measure this. It's measurable. 4, if you increase the permeability of the intermitochondrial matrix and you're letting hydrogens go through naturally, you'll still do oxidative phosphorylation complexes 1 through 4, but you will not make ATP anymore. In effect, you have uncoupled these two processes. Right, so taking it all into consideration, we can look at some of the math of this. So as we just said, complex 1, 3, and 4 are transferring our protons from the matrix to the intermembrane space. The force that can be generated, or the free energy, is called the proton motive force, or PMF. So the PMF is going to power ATP synthesis. And we can calculate the delta G of this, where delta G equals 2.3 RT pH of the matrix minus pH outside plus ZF delta theta, where Z is the charge of the proton, F is Faraday, and theta is our membrane potential. So we can take the membrane potential to be roughly 0.168. pH is roughly 0.75 higher in the matrix than the intermembrane space, so delta G is roughly 21.5 kilojoules per mole. Now, making ATP takes somewhere between 40 to 50 kilojoules per mole, and all in all, 3 protons are needed per ATP synthesis. And that's it for this video. I will see you in the next one.